Continuing in our booklet, we're going to do page 71 now, and it's to convert two exponential equations from a logarithmic form. Now, in our class lesson, we should have given you something like this, and this probably will be useful. So if you would, copy this down into your booklet here. And that is the general form of the logarithmic equation. And it's log of base of an answer equals an exponent. And we'll see that here very shortly. We'll just want to give the background. Now, the exponential form, the form that you want to put it in, converting it from its log form to its exponential form, here we're going to have a base raised to an exponent gives you an answer. So that's what we want here. Now, when we see a log in this form, this is actually log of base 10. They're just not writing it. When they have log without a base, it is the common log, base 10. So we want to see what is our base here. Well, our base here is 10. Now, base exponent. Well, in the log form, the exponent is here. So that'll be to the fourth. And now this is in the position of answer, and that'll be 10,000. So, keeping this in mind, because we'll be erasing it as we raise it, what is our base here? Well, our base is 10. What is our exponent? Well, our exponent is here, so that's going to be a -2. And that's going to equal the answer, which is, another way to write this is 1/100. But you could write it in its decimal form also. So again, if you keep this little hint helper in mind, converting from logarithmic form to exponential form, and then later, I'm sure they're going to ask you to do exponential form, converted to logarithmic form. Keeping our helper in mind now. Our base is 2. Our exponent is 3. And our answer is 8. Our base is 4. Our exponent is 1/2, and our answer is 2. And the half power is the square root of 4. So for number 5, our base is 6, our exponent is -2, and our answer is 1/36. Again, you really need to practice, and it gets to be, with practice, I think you'll develop mastery. Get on to page 72. Again, I would write this up there. This is the procedure we're going to follow, going from exponential form to its logarithmic form. So they want logarithmic. First thing I'm going to do is write down log. Now, what is my base here? Well, my base is 2. What is my answer? Well, my answer is 4. And what is my exponent? 2. Now here we're going to use natural logs. So we're going to use natural log. Now, if it's natural log, our base is e, which we don't usually write. And what would our answer be? Well, our answer is going to be 20.0855. And what is our exponent? And our exponent is 3. So again, if it's natural log, we don't have to write the e. So even though we know it's there, we could take it off of there. So it would appear like so. Here, they want us to write it in logarithmic form. So log base 7, our answer 343, and our exponent is 3. Again, change from exponential form to logarithmic form. Well, log. Now what's our base? Our base is 10. But if it's a common log, we don't have to write the 10. Our answer is this. Let's see, 1, 2, 3, 4, 5. 1, 2, 4, 5. 100,000. And our exponent is 5. Now again, we're not writing the 10, but this is how they want you to write it. And hopefully you're catching on. Changed from exponential form to logarithmic form. Well, log. What's our base going to be? 9. What's our answer? 6561. And what's our exponent? 4. Okay, again, something easy, but it does take some learning of what the formula, what the protocol is. Now, for example 1 here, they want us to, and we are on page 73, they want us to evaluate now a log. Well, often the easiest way to do this is to convert it into its exponential form. So here we know our base is going to be 4, and we're going to raise 4 to what exponent to get the answer of 1 over 64. Well, if you know it, then it's easy, but thinking about it, since this is going from a 4 to some fraction, your exponent's going to be negative. And then what power of 4 is 64? Well, a 3. So your answer here is a negative 3. This, again, is going to equal what value here, what exponent? And that would be a negative 3. All right, here's sort of an easy one. Our base is 2. 2 to what exponent is going to be 8? Well, 2 to the 3rd. So this equals 3. We have evaluated that. In example 3, now what is our base here? Our base, since it's not written, is our common log, 10. And our answer, we're going to raise that to some exponent to get 100. Again, they kind of gave us a hard one. Now they're giving us some easy ones. Well, this is going to be 2. that 10 to the second power is 100. Now they're asking us to evaluate this. Again, our base here is going to be E, and our answer is E. So what is our exponent? Well, it would be a 1. And there's a couple of other ways that I have shown you in the lesson part, the textbook part, of how to get this. That this is, in a sense, natural log of E to the E power. And there's a 1 up here, so this one ends up over there as well. Here our base is 8. Our answer is going to be the square root of 4. I could put that over here, but I could just say it's going to be 2. Square root of 4 is 2, another way of looking at that. So what would be the exponent when you have a large number that's going to give you a smaller number? And the answer is 1/3. Now you may recall from earlier lessons, this is the third root of 8. 8 to the 1/3 power is the third root of 8, which is 2. So this equals 1/3. In our lesson, we went over the change of base formula. To summarize it here, if you have something that looks like this, that the log of base A of x, you could put this into your calculator as the log of x divided by the log of A. That is, in essence, a shortcut to the change of base formula. Now, you could also use from this the natural log of x divided by the natural log of A. Either of these will give you the same answer. So, we want to find what this is. So this will be the log of 4 divided by the log of 6. Put that into your calculator and you get approximately 0.774, and they're asking you to round to 3 decimal places. Now, when I originally did this, I was rounding to 4 decimal places. So if I were to put that into MATLAB, 4 decimal places, when they're specifically saying 3 decimal places, they would count it wrong. So be careful of the instructions they're giving you, and that's what you need to follow. Now, on a blue sheet, of course, I'm able to give you overwhelming partial credit if you put 4 and they only wanted 3. You had the right answer, you knew how to do it, you just messed up on the procedure there. Now for number 2, while we're here, it'll be the log of 8 divided by the log of 1/3. And of course you'd put that in a parenthesis and then hit enter. This is the wonderful part about it. And you're going to get a negative 1.893. And hopefully you're using your calculator to support this as we go on. So for number 3, log of 8 765 divided by log of 36. This is the change of base formula, and this is approximately 2.533. And this will be the log of 1/9, that we'll put in parentheses, divided by the log of 72, which is approximately 0.514. And for number 5, this will be the log of 45 divided by the log of 62.8. That is approximately 0.919. So again, as long as you know the change of log formula, this is it. Now remember, you could have always substituted natural log of this divided by natural log of this. The answers come out the same.